Welcome back to School of Physics. Today in this lecture we are going to discuss about the accelerated frames, the frames of references which are accelerated with respect to some another frame, and the result of that there arises a force which is called the pseudo force. We will discuss those very forces also. So today's lecture will be all around the frames of references. So first of all we will consider two frames of references. One will be the inertial frame of reference and another will be non-inertial. So consider two frames of references. Okay, let these be S and S prime, and I will draw it down here. Let this very frame of reference be, and it is I am discussing all of this stuff in two-dimensional only, because later on it will be applied in the same manner for 3 dimensions also. So this will be frame of reference S, and another frame of reference will be like this very frame of reference. It will be S prime. What does that mean? We are considering two frames of references S prime, while this very S prime, this frame of reference is inertial frame of reference, and this very is non-inertial. Okay, what the inertial frame of reference and non-inertial mean? Now, it is inertial frame of reference means that very frame of reference in which the Newton's law of inertia is followed. That means simply this very frame of reference, it follows law of inertia, and you have already seen, and you might be well aware about the law of inertia, as you have seen in the first few lectures. So, and the non-inertial frame of reference, in this case this law of inertia is not followed, that is not valid. Law of inertia not followed. So we have considered the two frames of references. One is inertial frame of reference and another is non-inertial frame of reference, and we have to discuss a particle, a body, which is under force, or maybe in the absence of the force, what kind of dynamics that body observes and that body follows in both of these references, with respect to this very reference and then with respect to that very reference. Okay, so consider a particle, a body here, a particle inside this very frame of reference, and ultimately that will be also in this frame of reference, because these are two observed, these are two, like this is origin of this, and this will be O prime, the origin of second reference. So there will be the observers observing this event which is happening with that very body at two different frames, at two different origins. Okay, so consider a particle here, some particle P, okay, and the particle is at a position vector from the inertial frame of reference. It will be at a position of R. Say this is the position vector R with respect to frame of reference S, and with respect to frame of reference S prime, its position vector will be given as this R prime. Okay, but here is another thing. This origin of the frame of reference S prime with respect to S, it is at a position R, capital R. Okay, so that means S R prime is the position vector of O prime with respect to O, that is S prime with respect to reference reference S. Okay, this is the position vector, or the position vector of this very point particle P, position vector of P with respect to O, that is the frame of reference S, and R prime is the position vector of P, with respect to this very origin, that is the non-inertial frame of reference, that is O prime. Okay, get these things in mind. R prime, sorry, this is R, capital R. Capital R is the position vector of O prime with respect to O. Fine. R is this very position vector and R prime is this very, that is with respect to O prime. Fine. So applying this very thing, it will be seen like this, like this, like this. This is the point P here. This is O here, and this is O prime. Fine. So it will be this vector will be like R. This vector will be R prime, and this vector is R. Okay, and you have you might be already aware about this very thing, the triangle law of vectors and the addition law. Okay, from that very law you can easily see that this vector plus this vector, that is summation of vectors which are heading in the same direction, that is the this very tail of one is touched by the arrow of the other. These two get added, and that addition of these two vectors is equal to the third, which is in the opposite direction to these kind of things. Say here we are moving from this very position to this, then in the same direction here, but when we move from this very point to this, the arrow gets reversed. Okay, so it is simple to recall that here R, this very thing, R will be equal to the addition of these two vectors, that is R plus R prime. Okay, this is from the law of addition of the vectors, addition law of vectors. Fine, that is the addition law of vectors. So that means we will be having the position vector R, that is this very position vector R, will be equal to this R, that is the position vector of O prime with respect to O, R plus the R prime, that is the position vector of P with respect to O prime in the frame of reference non-inertial. So this will be from addition law of vectors, fine, which is discussed here. So now we are concerned with the acceleration of this very particle, whether it is acted upon by some force or not, because from the second law of motion we know that if this particle is acted upon a force, then ultimately that will definitely cause an acceleration inside that body, and if the acceleration is zero, is not observed, that means the force is not there. So we have to observe this kind of stuff here, that whether the force is applied onto this body or not. So to get that acceleration, we know the acceleration is the double differentiation of position vectors. So with respect to this O, that is the inertial frame of reference, we will calculate the acceleration of this body, and for that we have to differentiate it twice, and that is the double differentiation of this very thing with respect to time. So first of all, we will differentiate this very equation, differentiating this very equation with respect to time. Okay, so that means we will get R position vector, this differentiation, that means dot. I have already told you that this is the representation of dr by dt. Dot means differentiation of the vector with respect to time. Okay, so I will shortly represent it now onwards dot. This is not so much because it is shortly represented like this. So this is equal to this. R dot will be equal to this very R dot. Change of this, because we are considering this as the non-inertial frame. Okay, non-inertial means it does not follow the law of inertia. That means it may be accelerated with respect to this very thing, and we will get the acceleration of this very body, of this very frame of reference with respect to this, and that is given to as acceleration of s prime with respect to s will be the double differentiation of position vector r, here r, with respect to time. Okay, this will be the acceleration of frame of reference s prime with respect to s. So applying it onto here, first we will differentiate with respect to time, so we will get dr by capital R, dr by dt, that is r dot, that is the velocity of this very frame of reference with respect to this, because r dot means velocity, plus r prime dot. Okay, so this very thing will give the velocity of the particle, this particle in frame of reference s prime. Okay, now we are concerned with acceleration. So till now we got velocity in the frame of reference s equal to velocity in the frame of reference s prime plus velocity of the frame of reference s prime with respect to s. I have drawn this is s prime, frame of reference with origin O, and this is s with respect to, and its origin is O prime, so its position vector is r, and a point considered here, say its position vector with respect to this very thing is r prime, and with respect to inertial frame of reference its position vector is r. Okay, so the velocity comes out to be v will be equal to v prime, that is with respect to this very frame of reference s prime, plus v0. This is the velocity of origin of non-inertial frame of reference with respect to inertial frame of reference. So again differentiating, again, because we are to calculate the acceleration, again differentiating this very equation with respect to time, because acceleration is the double differentiation of the position vector. On single differentiation we get the velocity, now we will double differentiate it. So we will get the double differentiation of r, that is r prime double dot, that is the acceleration, that is dv by dt, that is acceleration. Okay, and this acceleration is the acceleration of this particle p with respect to frame of reference s. Okay, plus is equal to acceleration is equal to v prime. V prime is the velocity of the particle p with respect to origin O prime, that is in the non-inertial frame of reference. So we will get acceleration, that is the differentiating this very thing, that is acceleration, velocity, again we will get acceleration but in frame of reference A prime, in the frame of reference S prime, plus v0 is the velocity of this frame of reference, S prime frame of reference as a whole with respect to this frame of reference. So differentiating the velocity of the frame of reference S prime with respect to time, we will get the acceleration of frame of reference with respect to origin O. So this is the acceleration, acceleration of this particle p in S, that is inertial frame of reference, inertial frame. Okay, So this gives the acceleration of the point particle p in the frame of reference s, and this a prime, it's a vector quantity, this a prime is the acceleration of p point particle p in the frame of reference s prime, in s prime. Okay, and this very thing a naught is the acceleration of the frame of reference. This is the acceleration of the frame of reference of the frame s prime with respect to s, because this very frame of reference, it is moving with respect to origin a with some acceleration a naught. Okay, so it has got acceleration of a naught with respect to origin a. So this o prime is accelerated, and this very acceleration gives generation to the forces which are called as the pseudo forces, which we'll discuss in a bit later time. Okay, so till now we have got this very acceleration. So for any two frames of reference, if we have inertial frame of reference and a non-inertial frame of reference, so in that very case we will get the acceleration of a point particle in the frame of reference, inertial frame of reference, equal to be the acceleration, the actual acceleration which is caused onto the body inside that non-inertial frame of reference, plus times the acceleration with which the frame of reference itself is moving. Okay, so this gives the acceleration of that point particle. Now we have to calculate the force acted onto that very point particle. And to calculate the force, we know we have to apply the second law of motion. Second law of motion says that force is equal to mass into acceleration. Mass times acceleration gives the force. And consider the point particle p, it has got the mass m. Okay, so we have to multiply this very equation. Say this is equation a, this very equation, multiplying throughout it with m, multiplying equation a with m, that is the mass of the point particle throughout. Okay, so what will we get? We will get mass times a equal to mass times a prime, because mass does not change even if the particle is inside a frame of reference which is non-inertial, plus times mass times a naught. Good. So we will get mass times this, and mass times this from second law of motion. This is second law of motion. Okay, from that ma is the force. So we will get ma equal to, which implies ma will be equal to the force. This very force is onto this particle p with respect to the frame of reference s. Okay, force will be equal to this, equals m times a prime plus m times a naught. This gives the force acting on a particle which is studied under two frames of references, s prime and s, inertial and non-inertial. Okay, so if we need to apply this, what does this mean? This very thing, this is the force acting on the particle p in the frame of reference s prime. Okay, this is the force, this is the actual force which is acting on this particle p in the frame of reference, this S prime. Okay, so if we have to calculate, if we have to apply second law of motion on this very particle in the frame of reference S prime, for that what we will need to do, since this gives the force, but this is not all there it is, but there is an additional term. There is an additional term, this ma naught, and this is also the force. This is also the force, but this force is due to the accelerated frame of reference. Accelerated frame of reference. Frame of reference S prime. Because we know A naught is the acceleration of frame of reference S prime with respect to S. This is acceleration of this very frame with respect to this. So this gives to the origin, this gives the origin of another force inside this equation. So in order to apply, I will write it down here, in order to apply, if we like to apply second law of motion in an accelerated frame of reference, which is here S prime, this very frame of reference. If we want to apply second law over onto this, then what we will need to do, we have to add addition of an extra term. Addition of extra term is needed. Extra term is required. How that is, look, so we have got till now, we have got F is equal to m times A prime plus m times A naught. This is the frame of reference acceleration, and this is the acceleration observed in the frame of reference S prime. So we can write it down as, we want to apply a second law of motion onto this very thing. So that is the frame of reference S prime. F m times A prime will be equal to F minus times this thing. And this is the force which we need to add if we want to apply second law of motion over onto S prime. Okay, that is frame of reference S prime. So for that we have to apply, we need, that means we have to add an extra term. We have to add an extra term which is called as fictitious force, because this is also a mass times acceleration. This is also a force, but it is not force which is exerted by any external agency. It is the force which gets its origin from because of the acceleration of the frame of reference. Okay, because this frame of reference, this very thing S prime, is accelerated with respect to O prime, which is the acceleration here. So this very accelerated frame of reference, this very acceleration gives the origin to the extra force, which is here, this very force. And this very force is called as the fictitious force. Fictitious force. Or it is also called as the pseudo force. The pseudo force. This extra term we need to add, that is the minus times this very thing. Minus in this case because it is opposite to that of the acceleration felt inside O. Okay, because so for that very term to get second law applied onto this very frame of reference S prime, we need to add an extra term minus m times A naught. Okay, this very, force is called as the pseudo force. For example, take the case if the particle is considered at rest in the frame of reference S. Okay, we have considered the frame of reference this S, and then extra frame of reference here it is S prime. We have particle here P. We have considered this very particle at rest with respect to this very frame of reference S, inertial frame of reference. So no force is observed inside the frame of reference S. That is here, this equation A. So F will be equal to 0. Sure. So applying this very equation here, so we know F is equal to m times A prime plus m times A naught. These are all vectors, okay? So applying here, we know the particle is at rest with respect to the frame of reference S. That means this very force is 0. That is 0 equals mass times A prime plus mass times A naught. Fine. So on rearranging, we will get here m times A prime equals minus times m times A naught. Okay, this is simple. So that means even if because m times A is the force, okay, and this is the pseudo force here, and we will represent this very force F prime, that is the force experienced by that very body in the frame of reference S prime, that is m times A prime, will be equal to minus times A m times A naught. That means even if the particle P is at rest in frame of reference S, that is A acceleration is 0 inside the frame of reference S, even then the particle P experiences a force, which is this very stuff, this very force. And that very force is, it is not because some external force is applied onto this. No, it is because the frame of reference O prime is itself accelerated, and that very gives the origin to that force. It experiences a force which is called as the pseudo force, or the fictitious force, pseudo force or fictitious force. So this very force is actually the pseudo force. Pseudo force. It is not somebody from the external side applying some force onto this. It is due to the accelerated frame of reference. Okay, that is S prime, because S prime is itself accelerated with some acceleration A naught, that gives the origin to that fictitious force. And if the acceleration is in this direction, that means the force experienced by that very body, it will be opposite to that. This is the meaning of this very minus sign. This means the opposite to A naught. That is, if this frame of reference is accelerated in this direction, then the force experienced by this very body will be opposite to that of the acceleration, and that very force is actually the pseudo force. It is not some external body which is causing the force onto this body, but it is due because of the accelerated frame of reference. So that was the origin of force, which is not actually the force. It is observed because by applying the second law of motion in a kind of the wrong perspective, because this is not the actual force which is applied on the body. It is only due because of the accelerated frame of reference. Hope you got this very concept clearly. If you have got any suggestions, any queries regarding this very thing, kindly comment in the comment section. I will see you in the next.